The spatial resolution, again, is given by this formula. Means A plus B, sum the element to the left, minus the element to the right, divided by all of them to normalize, and you get the x. The same thing for the y. However, the contribution of the energy of this B is very little in the formula, and will change very little x, so this will give a big error in determining the good position, spatial position of these photons. Instead, if I get the energy to the left and to the right of the element who got the hit, to the top and to the bottom of the element who got the hit, sum them up with this other formula, so undoubtedly I'm getting a better resolution. Then clearer picture. Clearer picture is, you get a clearer picture when you have high statistic. Means you have a big number of photons. In fact, why now the patient has to stay 10 minutes on a position? Because you must accumulate a certain number of photons to have the picture. Now, instead of having the detector 16 centimeter, means this long, if we have a longer detector, we will take all the photons with an angle. I'm looking at the figure F. Okay? So, and this will increase, we will see, by the number square proportional to the linear increase of the length. And all this is done with the innovation of what I call 3D flow system, that is a parallel processing system, but implemented in a certain way in electronics that will facilitate the implementation at lower cost. So let's address a little more in detail this great advantage that it will justify the 400 times together with the electronic. So, as it is now, please correct me, Paul, Jelabek, and Bob, you know better. If most of the PET scan on the body, not on the head, but on the body, they are acquired with what is called septa. Septa are a ring of lead. Is that correct? Because the current electronic cannot discriminate, cannot filter the scatter events that are coming from outside with an angle. And so they found the best way, let's do it mechanical way. Mechanical, just put a lead, and at that point we will only capture the photons that are vertical and hit perpendicular the detector. And this explains also why when I talk to some doctors, they say, we don't need a long detector, we don't need 1.5 meter detector, because the largest organ in our body is 15 centimeter. So we just need something that is 15 centimeter. The reason why they tell me that is because they think that this is the only way to do it. It's only possible to do this. And however, I'm sure that if I tell to the doctor, say, well, if you increase and you put something that is 15 centimeter here in the center, but then you get also the one with an angle, and you get 4 times if you double, then your scanning time is cut down, your radiation is cut down, your resolution or image gets better. Okay, so this explains why we get this usual answer. We don't need a PET longer than 15 centimeters because they are referring to this technique. However, let's make an example. A, B, C, D, E, F. Sorry if I sound elementary for someone, but this is a very important concept for somebody who is listening and would like to know more about this. If we eliminate this septa, this ring of lead, and we can capture the photons that come with an angle, then there are 9 possible coincidences that we can detect with this. If we double it, it's not going to be 18, but it's going to be 36. Because we are not going to get from A to M, but we are getting also from A to P and from L to D that before could not. So if this concept is clear, then you will realize that all my claims are possible, and the only thing to prove is the electronic. Is the electronic capable of doing this? So here is a little bit the history of this machine. We go from a dual head coincidence camera to the ARC. This was developed in Geneva. By the way, I saw that a long time ago. And then these are rotating 2 arcs of detector. Then the Quest, then the full ring, ECAT from CTI Siemens, Advanced from GE and Positron. And then I would say, if we go to the 3D CBS, then we see the big jump over 400 times and the lower cost, and that is the great advantage. Now, who will want the 3D CBS, the market for this? As I mentioned, freestanding diagnostic. Why this mobile unit? Is because a hospital, a small hospital that cannot afford the capital of $3 million for the machine, they have maybe the patient for 1 day a week. So they should be able to get this machine, as there are several of these machines, MRI and so on. And so they can get on the parking lot of the hospital for 1-2 days per week the PET scanner. Oh, that's right. Larger hospital can purchase, if they can provide patients every day. This is capable of screening 30 patients. Then clinics, and then pharmaceutical company. I said for the very interesting possibility that they will have to monitor the entire body and to see the efficacy of the pharmaceuticals on not just on the detail, but all over the body. So it's a market that is growing rapidly. Now it's over 1,000 units. Started in the year 2000 with 250. So there is a investment highlights is a large growing market for medical diagnostic, and it should and will replace the CT because it's included in the CT also. Opportunity to increase the market size, strong patent position, and then so far all my claims remain unrefuted. So if they should not remain unrefuted for a long time, we should have the machine at a certain point. The industry dynamics, the CT scanner market was 2.4 billion in 2002, and is not growing that much. Instead, the PET started by CTI Siemens, but in the year 2001, GE outsold with 31% shares Siemens and Philips. FDA approval procedure.